Good day, everyone. Today's video is the first of the three videos about the physics that governs skin's elasticity. Have you heard about the saying, don't judge a book by its cover? Look at the hands of the person here. Can you guess the age? Is it in the 20s, 30s, 40s? How about here? Can you guess who among these persons here is younger or who is older just by looking at their hands? If books are judged by their cover, sometimes or most of the times we are judged by our cover, which is the skin. Our skin, as a covering, acts as barrier, protecting your body from harmful things in the outside world such as moisture, the cold and sun rays, as well as germs and toxic substances. Our skin is an elastic material. Somehow, it has the same property with rubbers, spring, or latex. Try pinching your skin like this. It shows that our skin is elastic because it goes back to its original form after the pinching is done. By the way, how far it goes? Has it gone this far? Well, if yes, then you are special. Meet Gary Turner. He can stretch the skin of his neck like this. The stretched skin of his neck can be used to cover his mouth. And look at the stretched skin of his body. Gary Turner holds the current Guinness World Record for the stretchiest skin as of October 29, 1999. He can stretch the skin of his abdomen to length 6.25 inches. Do you envy him? Hold on. That is not unusual because that is a type of skin disease called Ehlers-Danlos syndrome. What makes the skin elastic? A healthy and hydrated human skin has the capacity to stretch and then return to normal when released. This process is controlled by two abundant proteins, collagen and elastin, which are found in the muscles, skin, and bones. While collagen gives structure to the skin, elastin allows it to stretch. This is a normal skin structure. So we have the dermis, the epidermis, hypodermis, elastin, collagen, fibroblasts, and fat cell. Elastin provides benefits to skin function beyond solely mechanical elasticity. By acting as a substrate for cell growth, elastin can support improved regeneration and remodeling of the dermis, which is critical for effective wound healing and scar repair. Elastin is a major component of tissues in your body that require stretchiness, like your lungs, bladder, larger vessels, and some ligaments. Smaller amounts exist in your skin and ear cartilage. How important is elastin? Elastin's main function is to allow tissues in your body to stretch and shrink back. Your arteries are tube-shaped blood vessels that carry blood from your heart through your body. Elastin gives your arteries stretching characteristics that makes it easier for your heart to pump blood. Elastin allows your lungs to work like an elastic bag. When you breathe in, your diaphragm contracts or tightens. Your lungs create potential energy as they contract, and the elastic tissues in your lungs store that potential energy. When you breathe out, the potential energy in your lungs is released as your lungs shrink back. Damage to elastin, which is the elastic tissue present within the body, usually happens due to age. As people grow older, the production of elastin decreases and begins to break down, thereby losing its elastic property. This makes the skin stretch and hangs loosely. There are some factors that facilitates quick aging. Number one is exposure to sun. Daily exposure to too much sun can damage collagen and inhibit the body from producing new collagen. It increases wrinkles and the skin becomes stretchy. Also, ultraviolet or UV exposure can break down elastin fibers, making the skin saggy. Number two is smoking. Increased production of enzymes called matrix metalloproteinase or MMPs happens due to smoking, which can degrade collagen in the skin. An increase in MMPs can also inhibit collagen synthesis, making skin hyperelastic. Number three is dehydration. When a skin lacks adequate water, it starts to become thin and begins to sag. Less intake of water, adverse climate conditions, overconsumption of dehydrating drinks like alcohol, as well as certain diseases can cause dehydration. And number four is loss of fat. Loss of fat can cause results in the loosening of the skin. Hyperelasticity is often found in people with Ehlers-Danlos syndrome or EDS. EDS is a collective group of genetic disorders that alter the connective tissues that play a vital role in structuring and supporting the organs, bones, skin, and blood vessels in the human body. EDS emerges due to a defect of certain genes that affect the collagen and in turn makes the connective tissue much weaker. This overall process of EDS, due to mutation in the genes, causes excessive stretchiness in skin. Now, here's the thing: collagen, elastin, fibronectin, laminin, and others are considered as ECM or extracellular matrix proteins. The body is made up of organ systems that are made up of organs. Organs are made up of tissues, and tissues are made up of cells. But just how do the cells in the body form tissues in the body to create the higher levels of organization? The answer is extracellular matrix proteins. Extracellular matrix is the reason for cell adhesion. When we say cell adhesion, it is the binding of a cell to another cell or a cell to an extracellular matrix component. It is also one of the reasons for the collective cell migration, which is a very important component in wound healing and also scar repair.